I needed. Okay, so what I want you to do is there are two criteria that need what?
It's not centered in box.
Oops, thank you. So, thank you. Can I make my box bigger? Okay. Next time when I record, I'll do the full screen. Okay. That's all right. Thank you, though. All right, so two criteria. F is continuous on that closed interval, and these are the two criteria. K is some number, and it's a y value. Okay, K is a y value somewhere between f of A and f of B. So then, if those two criteria hold true, then the intermediate value theorem says there is at least one C value that's between A and B, so C is an X value, and K is a Y value. All right, so if you look here, I have F is continuous from A to B. Okay, F is continuous on the interval from X is A to B. The Y value is continuous. Then you see this C2 is in between A and B, and this K value is between F of A and F of B. So there exists a C such that F of C equals K. Then here, F is not continuous. So there is no guarantee. There is no guarantee that F of C equals K. So let's look at example 1. The function f of x is continuous on the interval from -3 to 9 with f of -3 equals 0 and f of 9 equals -12. Which of the following would be a correct statement concerning the existence of a value C by the intermediate value theorem? So go ahead and think about it. Now this is multiple choice, so we don't have to do this formally. So what I like to do until I get the hang of this, I'm going to plot -3, here's 9. F of -3 is 0, f of 9 is -12. It is continuous. And so, like, this could actually go up. It could do all sorts of things. So now I want to look at these options. F of 12 equals 0. What do you think about f of 12 equals 0? It's not in between -3 and 9, correct? So that one's a no. F of -1 equals -13. What's wrong with this piece? It's not between the 0 and the -12, so that's a no. F of -2 equals -10. Okay, so -2 is in between -3 and 9, and -10 is between 0 and -12, so this is a maybe. And then what about f of 8 equals 1? It's above the 0, okay? So we don't know for sure. The intermediate value theorem doesn't guarantee it. So it's letter choice C. Once you get the hang of this, the intermediate value theorem is pretty simple, okay? It really is pretty simple. And in pre-calculus, is this ringing bells? Did you do this? No? Okay. Over my career, when I taught pre-calc, we did do intermediate value theorem to help us in like a problem in example 2. It was finding zeros. That was one of the main purposes because we didn't have graphing calculators, so we needed a way to determine zeros on an interval. So example 2 says, use the intermediate value theorem to show the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 on the interval from 0 to 1. So what I'm going to do is I'm going to go find, see, they didn't give me any values, but I have a function equation that I can figure this out. If I plug in f of 0 into f of x, that gives me negative 1. What's f of 1?
Mm.
1 plus 2 is 3. 3 minus 1 would be 2. Okay, and remember I told you, and we're going to write this down below. Actually, maybe we can just start it. It says, what two conditions must be true to verify the applicability of the intermediate value theorem? F must be continuous on the interval from A to B. So as I started writing, I went, uh-oh, we forgot to check in example 2 if f of x is continuous. And if this is free response, you have to state that your function is continuous. It is understood that all polynomials are continuous. So we would say f of x is continuous, and you don't have to defend that for a polynomial. The other thing we need to state is that f takes on every real number between f of A and f of B so 0 is between negative 1 and 2. So if you want a 0, that means y is 0. So you need to state f is continuous, and the y value we wanted was a 0. And that's between negative 1 and 2. So by the intermediate value theorem, and I'm going to use a new notation if I haven't used this one before, it is a backwards capital E. Have you ever seen that one? This symbol means there exists. Let me write it up here for you. This backwards capital E stands for there exists. And again, I'm taking you very, very high level here. Upper level mathematics, okay? So we're going to say by the intermediate value theorem, there exists a number C. ST is very common to abbreviate for such that f of C equals 0. So again, you're just going to need to get used to some notation here. By the intermediate value theorem, you can abbreviate that IVT. A capital backwards E is there exists a number C. ST is very, very common in upper level math to use as such that f of C equals 0. All right, let's continue on. So here is a free response example. And we're just going to look at part A. Now there are some parts to this that you don't quite know yet, and that's okay, and they're not important for what the part we're looking at. All right, so we have a column of x is 1, 2, 3, 4. We have f of x. And remember, we talked about this f prime of x represents instantaneous rate of change. We're going to learn that that's a derivative here in the next unit. We have g of x and we have its derivatives. So, well, we don't need the derivatives in this one. It says f and g are differentiable and continuous for all real numbers. G is strictly increasing. The table of values give the function in the first derivatives. And h, okay, h of x is defined to be f of g of x minus 6. I don't know why I typed it in there twice. That was goofy, but So differentiable and the f prime, g prime are concepts that are going to be taught in the very next unit. They're not pertinent to this question. However, what we need to know is f and g are both continuous. So h of x is continuous because it is composed of two continuous functions, f and g. So you always have to state that when you're doing the intermediate value theorem. Now the actual question says this: explain why there must be a value r such that r is between 1 and 3, such that h of r equals -5. So what we're going to do is we're going to go look at, so we know it's continuous. Now we're going to go look at h of 1. Well, h of 1 is going to be f of g of 1 minus 6. So we're going to go find those two endpoints and see if -5 is in between those two, okay? So let me give you a quick head start on me and go figure out h of 1. And if you're super speedy, get to h of 3 before I get started. So g of 1 is 2. F of 2 is 9. So h of 1 is 3. Did you get that okay? All right, then let's go do h of 3. It's going to be f of g of 3 minus 6. G of 3 is 4. F of 4 is -1. So you always have to state those two conditions. So I have -7 is less than, -5 is less than 3. So now I've met the two criteria. By the intermediate value theorem, there exists a value r on 1 to 3 such that h of r equals -5. Okay, so when you're doing intermediate value theorem, you have to state those two conditions. So this is just a part A of a free response question. It'll be quite some time before we're able to get to a whole free response question, like doing all the parts, because typically they have derivatives and integrals in them. All right, I want to give you a couple of minutes, and I want you to try these two problems. All these two are doing is, can you figure out whether the intermediate value theorem applies? If it doesn't, what of the two criteria is being in question? That's okay, but if, I'm not asking you, look, the second part asks you about intermediate value. So on that first one, yes, there is a value, okay? But you're right, does it guarantee it? Could you use the intermediate value theorem? All right, so on the left, let me do this one, then pause again to let you try it on the right, because I think we're a little bit confused. So there's the function f of x. You can see the piecewise function. You can see the graph. The first question on the left says, is there a value of c on the interval, and watch your intervals, -5 to 2, such that f of c is 2? Yes, there is a spot where the function equals 2. It's between x is -4 and -5. But the next question says, does the intermediate value theorem guarantee a value of c? And the answer is no, because f of x is not continuous on the interval from -5 to 2. Okay, there clearly is a place where y equals 2. But the intermediate value theorem doesn't guarantee it. Okay? All right, now try the second one. Okay, talk at your tables. Tell you if you said yes, yes, no, no, yes, no, no, yes. What'd you say? All right, let's take a look at this one. Now check the interval. This was -1 to 5. Is there a place that the graph crosses at 2? No. This is a no. All right, Dylan, I overheard your conversation and you had a wonderful explanation. Can you fill us in on what you said?
I said no. It does. IVP does not guarantee a value of c because f of -1 and f of 5 are less than the value given, so it isn't in the range.
Right, there you go. Okay. So remember that second criteria. So, where am I? 3.5, thank you. Okay, so 2 is not between -3.5 and -0.5, -1/2. Okay? All right, that finishes up the notes. So what I'd like you to do is go ahead and open and start. Or is there another one? There's not another one, right? Okay. Go ahead and start your homework.